Good afternoon, everybody, and welcome to MOS Live Virtual Planetarium, The Sky Tonight. My name is Karen. I'm one of the many educators at the Museum of Science, and today I'll sort of be acting as your moderator. And that just means I'll be keeping an eye out for all of your observations, your questions, your comments, and I'll be able to pass them along to our lead educator, who you will meet momentarily. Now, if you are watching here on Zoom, you can click the Q&A button and you can type in any question or comment or observation you may have. If you are watching on Facebook or YouTube Live, well, we are so appreciative that you are tuning in today and hope that you enjoy our tour of the nighttime sky. We cannot field any questions or comments from those platforms. And if you are looking for closed captioning, you can find the CC button also at the bottom of your screen. Click that and choose Show Subtitles. So with that, I want to invite Katie to come on camera and introduce herself.
Thanks, Karen. Hi, everybody. My name is Katie. My pronouns are she and her, and I will be your astronomy educator today as we explore the night sky. So I'll go ahead and share my screen with you. We're using, once again, Stellarium, which is a free open source program that you can find at stellarium.org. We'll have the link for you at the end of the show today if you are interested. And basically, we are just going to look at what is up in the sky tonight with an emphasis on some of the winter staples. So a lot of the constellations that are prominent in the winter time. So right now I have this set to about 10 o'clock tonight as seen from Boston. This is pretty similar if you're anywhere in the mid-northern latitude regions of the planet. It would be your 10 o'clock local time. And you can change the place if you're using Stellarium. You can look anywhere on the surface of the Earth or even on other planets or moons. You can change that setting and you can change the time as well. So we are looking in the eastern part of the sky, or maybe closer to the south, so the southeastern part of the sky. And let's just start by warming up a little bit. So if you want to make some observations about what you see, any particular objects that you recognize, or groups of stars, constellations, anything like that, go ahead and type them into the Q&A.
While we're waiting for some of those to come in, I'll notice that there's something very bright down over just above where the E is.
Yes, so right over here, this is the bright object I assume we were talking about, is the moon. So if we zoom in, yeah, it looks a little weird just because it's shown as just a bright kind of hazy patch of light. But if you zoom into it, you can actually see the moon in more detail and you can tell what phase it is. So this is approaching third quarter. So it's a waning gibbous moon right now.
Cool. Somebody asked, is that Venus? Which may have been that bright object that you just pointed out as the moon. Amber also asks, how do you know what the sky will look like ahead of time?
Yeah, that's a really good question. So basically, the sky doesn't change a whole lot. What we see up in the sky, it only looks like it changes because the Earth is moving. The Earth is spinning, right? So that's what makes it look like the sun rises and sets over the course of a day, or why the stars kind of slowly rotate around the sky. That's because of Earth spinning. And then there's also Earth's revolution, or its motion around the sun. So throughout different seasons, we see different groups of stars because the nighttime side of the Earth is facing a different part of space. So the stars are always fixed. They stay fixed. They don't really move relative to each other at all. From our perspective, they're so far away, and everything it stays the same. So we can predict where things are going to be and at what time of the day and things like that, just by knowing where things are and knowing how the Earth moves as well. Same thing with planets. So planets, we do see those change position in the sky quite a bit because they're a lot closer to the Earth. So we can actually see their movement, but we know how the planets move. We know how long it takes them to orbit and spin, and same thing with the Earth. So we're able to predict where things will be, and we're also able to go back in time and look, thousands of years ago or even millions of years ago and see how the sky was then as well.
was it for observation. So if you have things that you want to point out, I could keep making observations, but let you lead it, Katie.
Yeah, sure. So over here in the southeast, there is a really prominent winter constellation that some folks might recognize, and it is Orion the Hunter. So you can find him easiest by looking for his belt, which is made up of 3 stars right in a row, and they're roughly equal in brightness, or they look equal in brightness. So if you are looking at these 3 stars, you'd be correct. And then from there, you can find the rest of the constellation. So I'll zoom in just so that we can get a better look. So there's his belt, and then we can go up here to find one of his shoulders. We can go up the other way to find his other shoulder, and then he has 2 legs coming down in each of these directions, and then he has a really teeny tiny head all the way up here. And he's a hunter. So let me go ahead and connect the dots, or connect the stars on this constellation. Over here, there's like an arc of stars. So that's his bow and arrow, or some folks see it as a shield. Other cultures also see different constellations as different objects or creatures or people. These are not the only ones. These are just the mostly Greek and Roman ones. They tend to be the ones that we're most familiar with, but there are plenty of others out there, each with their own unique mythologies. Let me go ahead and show the art as well. So there he is. And sometimes he's depicted as being in battle in the sky with another creature. I was going to say object, but with another creature that makes up another constellation right nearby that I will bring up in just a little bit. So Orion is one of my personal favorite constellations just because it is filled with so many cool astronomical objects. I'm sure you've noticed that the stars that make up this constellation are very bright, like this one over here and this one down here in particular. Those are the 2 brightest stars in Orion, and they have different colors. So this one is called Betelgeuse or Betelgeuse. And it's actually a red supergiant star. So stars can come in all different sizes. I was going to say shapes and sizes, but they're pretty much all spherical or close to spherical. They come in all different sizes and also different colors because they emit light at different parts of the electromagnetic spectrum. So some stars will appear redder or bluer or white or yellowy or orange. So this star right here is a red supergiant. So it's very, very massive and large in size, takes up a lot of space. And then down here, we have a star called Rigel, which is also a very bright, larger star. And this one actually has a bluish color to it. So what do you think the color of a star can tell you about a star? And you can type that into the Q&A. And if you have no idea, you can just say that you're unsure, or you can type in a question mark if you want, or you can just take a guess. Whatever you feel comfortable with.
Age, how hot the star is, temperature, age, or distance, with lots of question marks also. So people are making those guesses, but perhaps just adding that question mark as maybe not quite sure and looking for more evidence.
Yeah, that's awesome. And those observations were really great as well. So sometimes age is something that you can kind of tell by the color of a star. It does require a little bit more research into the star, more observations in order to tell the age. But if you said temperature, how hot a star is, that is more directly related to the color. So a red star is actually going to be cooler than a blue star is, despite what we're used to when we are washing our hands and our sink faucets tell us that blue is cold and red is hot. It is actually the opposite. So things that are blue are emitting light and heat energy in a more energetic part of the electromagnetic spectrum. So if we're thinking about light, right, we see visible light with our eyes. It's just a small part of the whole spectrum. But then if you think about X-rays, like if you go to the doctor, or microwaves when you're heating up food, infrared waves are another one. So if you've ever played around with like an infrared camera or something like that, those are all other types of wavelengths of light that we can't see with our eyes. So different stars emit different light across the spectrum. So things that are hotter have higher energy wavelengths than things that are cooler. So the blue star, for example, here is toward the more energetic side of the spectrum. And the red star is more toward the less energetic side of the spectrum. So that's why blue is much hotter than red is. Now, they are both still stars. So while the blue star, Rigel, down here, might be tens of thousands of degrees, Betelgeuse is still a few thousand degrees on its surface. So it's still very hot. You don't want to go up and give it a hug or anything like that. So nice job, great observations. It's just a little bit about stars and their colors and light. Could go on and on about that, but we're gonna.
I have a question kind of related to that, Katie.
Sure.
So Amber asks, are the stars in his belt hotter than his left shoulder? Not entirely sure if we're still talking about Betelgeuse, but maybe just real brief about the stars in his belt's temperature versus Betelgeuse, Rigel, and maybe even his actual left shoulder star.
Yeah, okay, so the stars in his belt, which I don't know exactly what types of stars they are, but since they do appear more of a whitish blue, they are most likely hotter, much hotter than the red stars. So red stars are the coolest pretty much of all stars in the universe. There are some other objects that are cooler, but they're not quite classified as stars. So yeah, these would be hotter just because they are bluish or whitish in color. Same thing with the star over here. In comparison to each other, I couldn't tell you. I don't know enough about them individually, but most likely they are much hotter. And another fun fact about Betelgeuse in particular, the red star of his shoulder, is that it is running out of fuel. So it's actually nearing the end of its life. And that's part of the reason why it is kind of puffed up quite a bit. And then once it fully runs out of fuel, it will collapse in on itself under its own gravity, and then it will explode outward in a huge supernova explosion. And that's something that only happens to very massive stars when they run out of fuel. So our sun is not going to explode when it runs out of fuel. Our sun is an average star, so it'll just kind of puff up and shed its outer layers of gas. But that won't happen for roughly 4.5 billion years. So if you were getting worried, don't worry. Got plenty of time.
Don't have to watch for the sun coming towards us anytime soon.
Exactly. Yeah, so one other thing in Orion, I'll zoom in really quick, is this fuzzy patch here. This is a nebula. So nebulas are just giant clouds of gas and dust in space. There's all different types of nebulas that exist out there, but this one in particular is an area where stars form. So there's lots of baby stars in this cloud of gas and dust. And these nebulas, they can be really, really big. They can be, dozens of light years across. So they're also really beautiful. If you've ever seen pictures of them, or even here, you can see there's different colors and swirly gases. This is another nebula, a famous nebula called the Horsehead Nebula. You can zoom in even more and you can see it actually does kind of look like a horse, or maybe I think it looks closer to a seahorse personally, but it's cool either way.
You can see it from both. But yeah, seahorse, definitely the outline at least. But I guess when people named it, they probably didn't have a lot of experience with seahorses.
That's true. That's a good point. All right. And have there been any other questions before we move on to another constellation?
Two other ones that have come in. One of them is actually a stellarium question. So I think that our viewer has has been messing around with it perhaps, but asks, how do I show the outlines of a single constellation versus all constellations in the sky?
Yes,
I don't know if that's an easy answer.
It is. It's a very good question too. If you go over to the configuration window and you head to tools, there is a box that says select single constellation. And if you have that box checked, you can then select them each individually.
Perfect. So hopefully that is an easy answer and our viewer can play around with that after our show. And then the only other question that came in thus far, somebody asks, do all the constellations come with a myth or a story?
Yeah, that's a good question. So I think most of the Western constellations do have, or at least like the Greek and Roman versions have mythologies behind them. A lot of the constellations in the Southern Hemisphere are, at least from the official 88 constellations that the International Astronomical Union uses, a lot of those in the Southern Hemisphere are newer. So there's like a microscope and a compass and constellations that represent like instruments or celestial navigation. And I'm not sure if they have really fleshed out mythologies behind them. And then, of course, there are so many other sets of constellations from various cultures. And I think a lot of them do have mythologies behind them, but I can't say for certain that each and every constellation has like a fully fleshed out backstory.
I love learning all the different stories. Like Orion might be a hunter in Greek and Roman mythology. There are tons of other stories about this constellation alone. So I encourage people, if your local library is open, go check it out. Ask the librarians for books about, stellar myths. Really
Absolutely. Cool. Awesome. All right. Well, we can go ahead and move on to another constellation. So if we follow Orion's belt kind of up in this direction, it will take us to an area nearby. So let's kind of tilt us around here. We're facing kind of more toward the southeastern part of the sky. We'll follow his belt up here and we'll come to a V-like shape in the sky with one very bright star. So this is another constellation. And once you find the V, you can find the rest of it. It kind of comes out this way and then back down here. So if I click on it, you can see it's very strange looking. It's pretty hard to tell what this is supposed to be. But this is the constellation Taurus the Bull. So in mythology, in Greek mythology, there are some stories about Orion fighting the bull in the sky. And this little patch of stars right over here is sometimes represented as a wound in the bull from getting into this scuffle with Orion. But these two lines that come out here represent his horns. And then this star, this really bright star called Aldebaran, which is an orange supergiant. So it emits light primarily in kind of the orange region of the spectrum. But this star represents the angry eye of Taurus the Bull. Now, I pointed out this nebula in Orion, which, by the way, is called the Orion Nebula, but there's also one in Taurus the Bull, and it's not a nebula where stars form. Instead, it's a nebula where a star has died. So I'm going to see if I can find it. I know it's somewhere in this region. Let's see.
So amazing is that you can do it with this software where even if you had a really great telescope outside, zooming in, you're not going to get to see the nebulas like this. So I kind of love the computer software.
Absolutely. Yeah. So you can see there's a lot of nebulas in this part of the sky. And there's one in particular, which I think is in this region. Oh my goodness. I did not realize that there were so many nebulas in Taurus the Bull. But there is a supernova remnant. So it's basically the remains of a star that exploded in this particular nebula called the Crab Nebula. was the remains, or is the remains of a star that exploded about 900 years ago. And so now when we look at that part of the sky, we can see all these different colors and layers of gas that are still expanding out into space. They're still moving from that explosion that happened 900 years ago.
How do we know it was 900 years ago, Katie?
Yeah, so we have evidence that Chinese astronomers at the time saw what they were calling a new star in the sky, because when a star goes supernova, it gets really, really bright before it starts to dim back down. So there's all of these recordings and writings of a new star in the sky, and they kind of mapped out like which part of the sky it's in. And then it disappeared like a few days later because it faded away. And so now when we look at that same part of the sky, we see the remains of that explosion. We see the supernova remnant. So it's pretty awesome that humans actually observed a supernova happen. And then 900 years later, we're looking at it. We're looking at the aftermath through our telescopes.
I'm waiting for Betelgeuse. I'm still hopeful in my lifetime.
I know.
And somebody actually did ask, how can we tell that a star is about to, or is at the end of its life?
Yeah, another really good question. So when stars approach the end of their lives, so they're basically burning through fuel throughout their lives. So they convert hydrogen into helium, and then helium into heavier elements, and so on and so forth, until the star can't fuse elements anymore because there's just not enough energy. And that's what I mean when it runs out of fuel, is that it doesn't have enough energy in order to fuse a heavier element. So like iron, for example, is the limit for a very massive star. Stars cannot fuse iron. There's not enough energy. So that's when it breaks down. And so when we look at the light of a star, we look at its spectrum, each element actually has a signature, a light signature. So just by looking at the light of a star, you can tell what it's made of. And if we see a lot of elements like that are heavier, like iron or something like that, that's kind of toward the end part where the star is like, okay, I don't know if I have enough energy to fuse this anymore, then we can start to tell that a star is running out of fuel and that it's going to die soon. And when we say soon, you know, it could mean 100,000 years or so, or something like that. All right, so we've got a couple of constellations in the southeast, but there are a few more prominent winter ones that I want to point out. So if we follow Orion's belt, instead of going up this time, we're going to go back down. In a straight line, we come to a very, very bright star. And as a matter of fact, this is the brightest star in the sky. So if anybody knows the name of this star, go ahead and type it into the chat. Or if you want to just take a guess.
Vega, if a guess this come through. Sirius, spelled correctly as well, or close to correctly. Venus, the North Star.
All right, great observations.
And then the person called himself on the spelling error.
Awesome. Yeah, so a few of those objects are definitely very, very bright. Like Venus is the third brightest object in the sky, but it is a planet, so it doesn't count as a star. And then we have, someone said Vega, which is also a very bright star, and the North Star, which is kind of, it's a little bit bright, but that one's more famous because it's always in the north. This star is Sirius. So for the person who guessed Sirius, you are correct. And it's part of Canis Major, or the big dog. And if you are a fan of Harry Potter, which is known for having a lot of characters that are named after astronomical objects, this is where the character Sirius Black comes from, the star, and in the constellation of the big dog. So that's kind of a fun fact. So we've got Sirius down there, Rigel, Betelgeuse, and Aldebaran. So these are kind of like the four really bright stars in this part of the sky. And then there are a few others. So this constellation, we're going to kind of hop over to this really bright star. This constellation can get pretty complex. All right, so we're going to click on it and see if you can tell what this constellation is supposed to be. All right, so that's the entire constellation. All of that was sarcasm.
One of my favorites.
But it is supposed to be Canis Minor. So if you know what that might be, type that into the chat or the Q&A.
Is that the little line?
The little line, it should be.
And if folks were paying attention, what you said Canis Major is, so Canis Minor was a guess. That probably came in before you said it, but
probably.
That was, Q&A seems to be just a little delayed. A little dog?
Yeah, it's the little dog. It's very cute, so I'll put it up there. See, big and little dog. The big dog, I don't know. It doesn't really look like a dog, but it's okay. They're pretty cute. All right, and then two other constellations I want to point out. We've got two bright stars right here. You also see that this giant crab came up, and that's because when I clicked on the moon is currently in Cancer the Crab, so that's why that constellation popped up. But these two stars here are Castor and Pollux, which are part of Gemini, the twins. Another very popular constellation. And then we have right up here to kind of complete this part of the sky, we have Capella, the star called Capella in Orion, the charioteer. And whoever saw a charioteer out of this group of stars had a really good imagination.
Love the southern winter sky. It's such an amazing time to look at the sky. And we only have a few minutes left, Katie. We did have a really good question. I think I managed to, dismiss the question, but it was about the coming alignment of the planets. So I know I've seen articles about this as well with Saturn and Jupiter. So maybe you could just spend a minute or so talking about what it means and why it's so unique.
Yeah, absolutely. So if we bring time back a little bit so that we can actually see Jupiter and Saturn in the sky. So this is at around 6 o'clock and it is dark here in Boston at that time. We can see that Jupiter and Saturn are very close together in the sky. Now that doesn't actually mean that they are close together in space, because Jupiter and Saturn are nearly 500 million miles away from each other. It just means that they are close to each other they're on the same side of their orbits, pretty much. So we can see Jupiter, and then close behind, so 500 million miles behind Jupiter, we can see Saturn. This is called a conjunction, when it looks like two planets are on the same side and they're moving close together in the sky. Now this is pretty cool because they're going to get really, really close to the point where it might even be hard to see a difference between the two unless you have a telescope or a pair of binoculars or something like that. But conjunctions happen every 11 or 12 years or so. They're not always visible, but they do happen fairly frequently, and it's just a cool thing to see in the sky because it'll look like a really, really bright part of the sky, and then if you give it a little bit of a closer look, you'll see that there are actually two planets there. So it's just a cool thing to look out for.
So is it just when they say this hasn't happened in 800 years is what I saw? It's basically that in a good evening portion of our sky, we have not had this particular conjunction visible without staying up till 2 o'clock in the morning or having it be in the middle of our daylight. Is that where sort of hundreds of years come from?
I think so. Yeah, because it does happen a lot more frequently than that, for sure. I think it just depends on how visible it is. So I think you're right on that one.
Cool. Well, we are out of time, Katie. I'm sure you have so much more that you could share with us. The good news is we do the Sky Tonight presentations every Friday afternoon. You can always check back. It changes simply because the Earth keeps on trucking. So we have different skies to look at every Friday afternoon / evening. So I want to thank Katie for sharing the night sky with us. I want to thank all of you for being here. So Katie can give a quick wave.
Thanks,
you can give her a silent cheer. I hope that you guys enjoyed the show today, that you learned a few new facts. There were some questions we didn't get to, and I apologize for that. But I did try to answer a couple in the Q&A, so hopefully you saw those. And as Katie pointed out, we were using the Stellarium software, and it's free, open source. You can just go to that website and download it yourself, and you can explore the nighttime sky on your own. If you want to know exactly when we might be doing the sky tonight again, or any of our other museum science live streams, you can check us out at mos.org/MOS at home. And if you really like this one and have the ability to do so, we would love for your support. Keep the museum running through these strange times and beyond. So with that said, have a great rest of your Friday afternoon and hopefully a great weekend. Thanks so much, everybody. Bye-bye.